How's it going, guys? I'm back for the third time. And this time I'm presenting about something I love, Windows persistence. We're going to go dive in, see what's available out there, what you could apply to your next red team tool. Lots of cool stuff. Who am I? I'm Will. I'm the head of research from the best state in the world, New Jersey. Second year cybersecurity BSMS. Come on, man. Why are you laughing at that? I'm a red team offensive security focused type of guy. I'm into cooking, culinary, hockey, baking, coffee, hiking enthusiast. I'm a radical hummus lover. Whiteman's roasted garlic hummus, best thing on earth. I now ice skate like 2 to 5 days a week. I'm also now like a bowling enjoyer. I got my first turkey yesterday. It was crazy. And I spent roughly 25% of my income in 2024 on coffee brewing equipment. I know like way too many things about coffee. It's kind of weird. So what's persistence? Basically, if we go to MITRE, persistence consists of techniques that adversaries use to keep access to systems across restarts, changed credentials, and other interruptions that could cut off their access. Techniques used for persistence include any access, action, configuration changes that let them maintain their footholds on systems, such as replacing or hijacking legitimate code or adding startup code. Basically, what this means, this is how you're going to keep your malware on the system, which is what red team is all about. So when you're going into making a tool and you're a red teamer, you're going to want to say, you want to enter the mind of a blue teamer. You're blue teaming and you find Google Docs C2 is running on your computer and using 30% of your GPU every 120 seconds. What would you do? Hayden, what would you do? You would cry? What about you, Asa? You would let the malware stay there? What about you, Lucas? You find malware and you're a blue teamer. What are you going to do? You're going to delete the malware? What, you're going to delete the files? What about you, Adam Brachia? You find malware on your computer. What are you going to do with it? Leave it there? What about you, Leah Kavares? You're in a competition. You're a blue teamer. You're on CCDC. Yeah, probably hack back. You would hack back? What about you, Anthony? Malware on your computer. I use the red team hash cracker. Okay, Zachary. What do you do? Mr. Networking. Would you make a firewall rule, shut it off? Oh, yeah, you would. Garrett, what would you do? Pick a lock. You would pick a lock? What about you, Ariana? Big Mike, you got to have something for us. Throw it out the window. Philip? What about you? Leave it? Leave it? All right, so not the best answer as I was looking for, but if you're a blue teamer, there's some things that you're probably going to do. You're going to delete the file. You're going to change the file paths. You're going to change the file names. You're going to change the file access permissions. Maybe you're going to find and kill that process through a command prompt or PowerShell. You're going to restart your computer. Or maybe you're saying, I netstatted and this thing seems to be a C2 and it's communicating over these ports. I'm going to block those ports. Or you can even block networking from a certain exe file. So basically, you see this path. Don't allow any networking with that. Or you can inspect some of the most common persistence mechanisms. You know, you're like, oh, this thing keeps turning on when I restart my computer. Let me check the run keys and the scheduled tasks. So persistence is super important in red team. I'd argue it's almost what red team is all about. Penetration testing, that's where you're getting the initial access. Red teaming, you're given all the access you could ever want. You just need to be able to stay there and issue a bunch of breaks. So all of your hard work on red teaming would go to waste if you just had your tool be easy to remove. That's like 50 hours of coding, your 10 hours of debugging Ansible on Windows. It all goes to waste if they can just like kill the process super easily through Task Manager. And oftentimes the breaks are super premeditated. What matters more is that we can issue the breaks. And if you have no access, that means we can't issue breaks to blue team. And if you can't issue breaks to blue team, there's no challenge. And with no challenge, there's no learning and no fun. And who wants that? So persistence is important, but how do you do persistence? On Windows, it usually falls under 3 things. You got your registry keys. If you don't know, I'm going to explain it next slide, but it's like a hierarchical database in Windows that stores your system settings, configurations, or application preferences. With Windows, there's a lot of ways you can live off the land. Windows is pretty complex and has a lot of features just out of the box, and you can just like kind of embed stuff in there and use legitimate features for illegitimate reasons. You can also just schedule tasks like run this thing every time the computer restarts, run this thing at 3 p.m. on Wednesday, and it'll just do that. So that's also a great tool to have. So registry keys. Basically with persistence, there's these two registry hives you want to care about: HKey local machine and HKey current user. Basically that's configuring the local machine stuff or configuring the user's settings. The keys are like folders. They store these subkeys, and in the subkeys you can input some sort of data, which often in this case with persistence is just going to be a file path of something to run, a DLL or an EXE. And for editing the registry, you have a GUI and regedit. You could just use the command line, or you could do it through code, which is what I like to do with my tool. So why persistence on Windows? I think Windows persistence is a lot more fun than Linux because Windows is so feature rich and there's so many fun ways you can live off the land. You'll see some of them. You could use the disk it's the disk cleanup service that was with Windows Server 2003. You can make this registry key and then it's gonna bring about some future from 2003 and run your malware. It's crazy. And I knew C# best coming out of co-op, and C# it makes it super easy to interact with Windows system functions. And Windows just has so many fun ancient features you can use. With my Red Team tool, simpler was always better. It was a lot more easy to debug and maintain. So here are some of the methods. This is just a little taste of what's out there, and some of these won't apply to the newer Windows versions, so just beware. Not everything here is going to work on Windows 11. So here's the classic. You got run keys. They're boring. They're effective. This path is just burned into my mind. HKLM software, Microsoft Windows current version run. You put it in there. Every time you restart the computer, it's going to run. And most experienced blue teamers know about run keys. If you get any CCDC member, anyone who's done probably 2 or 3 blue team competitions, they're going to know about this, and they're going to be checking there. And if you put your stuff, if you put run keys in, they're probably going to delete them. So it's not very stealthy, but it's a great option. It's very simple to set up, and it's reliable. Schedule tasks. This is another classic. You schedule something to happen, it goes. You can try to give it a name and description that blends in with other tasks at a glance. That's what I like to do. You can have like Microsoft Outlook search indexing, just be like a random schedule task. And like if you're scrolling through it, like you're not really gonna notice at first sight. But then you think about it for a second, like why is that in there? But yeah, simple as that. Schedule tasks to run, including things like running malware. DLL hijacking. With Windows, you can identify an application that loads a DLL from a user writable path. You can use procmon for this. That's always a good option. Then all you need to do is drop a malicious DLL that the program finds before the legitimate DLL, and then now your payload's running and the application's executed. It's simple, it's effective, and just compile a DLL and it runs the payload. It's pretty simple. Windows services. This is a really powerful one. Another classic too. They start automatically on boot. They run as the local system account, which is very high privileges. They run undercover, and the GUI reveals only a small part of their real configuration. They're super cool. And all you need to do is configure them, HKLM system, current control set, /services. PowerShell for persistence. This is kind of delving into fileless persistence. It's pretty cool. You can set a registry key to execute PowerShell commands that will linger in memory and run other payloads. Obviously, remember not to pop a window when PowerShell is ran. That would be really sad. I think I've done that before. It's pretty revealing. And a privileged PowerShell session will really allow you to do whatever you want, and it gives you options to kind of do stuff without needing to create a bunch of files that blue teamers can just find and delete. WMI is another kind of fileless option. Did you pay attention to Advanced Windows last week? No, we didn't? Okay. Well, basically, it's a very extensive management tool that can be used to kind of remotely or locally manage things. It has syntax kind of similar to SQL queries. No one paid attention, so what happened? Oh, man. But basically, you use WMI instrumentation event subscriptions to trigger events of malicious code based on system events, such as like startup, logon, or process creation. It stores payloads in the WMI repository rather than writing to disk, and it makes things happen when the system starts up, when users log in, or when a process is launched. And then we're getting into the silly registry key section. Basically, there's some cool registry keys. This is the one I was kind of alluding to earlier. The boot verification key stores configuration to bootverify.exe, which is a program that was included in Microsoft Server 2003 that notifies the system that the startup was successful. This was only something I was able to find off of like one website on the whole internet. Like this registry key is almost nowhere except like a couple blogs and then like one weird person that maintains all the registry key descriptions. But basically, you go to current control set control boot verification program, plop in your image path subkey, and then put in the path to your malware, and it'll just run on startup as if it were a run key kind of. And you can just watch the magic of ancient code base running your software on reboot. As for another silly registry key, this one's it's a little cheeky, as we could say, and it's a screensaver. The screensaver just launches when idle, and what if we made it so instead of a screensaver, it was malware, which you can just do. You just head to HKU control panel desktop, and your binary will run as a screensaver if you put it as the key. Another silly registry key is image file execution. This was originally designed for debugging, and IFEO allows developers to specify a debugger to attach to any executable. And boom, now we attach malicious code to a legitimate process. So nice of Windows to do this for us. Basically, all we gotta do, attach our the run key we need, and it'll run with our malicious process. cmd.exe autorun. This is like just kind of crazy. Like they just built in an autorun function that runs something before CMD for you. So all you got to do is put it in there, and when blue teamers use CMD a lot, they open up CMD, and now your malware runs, which is awesome. Nice of Microsoft to do that for us. Keyboard shortcut. This is another fun one. Hotkeys allow specific keyboard input to trigger an LNK file. LNK files are shortcuts which can be used to which can be used to point to malware. The shortcut can be modified using the COM interfaces or by directly editing the LNK file to select a hotkey. And basically, you can have it so every time they press cap lock, that executes your malicious payload. And now pressing a key can just trigger your executable, which is pretty awesome. The auto dial DLL. This is a really obscure one, but basically, when the WinSock library connects to the internet, it talks to various service providers and probes them for connectivity services. And at some stage, it attempts to load a DLL as specified by the following registry key. So now if we put our malicious DLL in there, when it tries to connect to the internet, it'll just load your malicious code. And you can basically just control the DLL loaded whenever the computer is trying to connect to the internet, which is like every time. AMZ providers. AMZ is used to combat memory tampering from malware. And if you're a creator of anti-malware products, you can choose to author and register your own in-process COM server, a DLL, to function as an AMZ provider. So what instead of it being an anti-malware provider, the DLL was just more malware. And you can do that as well. And you'll just put malware in more places within the system. And there's many, many more. This was just kind of a small glimpse into what's out there. There's like so many ways you can make Windows just run your malware. And there's so many aspects of the OS you can make run your binary. There's a whole GitHub repo, persistence info GitHub. It's not super updated, but lots of cool stuff in there. Hexacorn is a blogger I pulled a lot of stuff from. They just make tons of really cool persistence techniques. There's like 120 like pretty niche, interesting persistence techniques on their blog. And there's just a lot of cool stuff out there, lots of interesting things you can do, lots of stealthy stuff you can do, and lots of stuff that nobody is really going to think of as a blue teamer. So when I'm saying all this, we're combining tons of persistence techniques. How do we ensure that only one instance is running? So basically, what I did with my tool, I combined a lot of persistence techniques, which did present the issue that, oh, now I might have like 50 instances of my program running at once, which would obviously be a huge problem for stability, for CPU usage. So if you have something running many times, all you need is mutexes. Mutexes are an easy and accurate way to control access to a shared resource in a multi-process environment. As you can see, you got threads. They're waiting for the mutex to be released. And you can just share the mutex between processes. So if they lock the process one mutex and then there's a million persistence techniques running that try to launch process one again, none of those are going to be like, oh, let's go and start running. They're just going to exit because they know that that mutex is already in use. So basically, the running process holds the mutex for the entire duration that it's running, and as soon as it stops running, another program can actually run and take that mutex again. But if so basically, it's just going to prevent the issues with your payload being ran too many times. So that's a good way to kind of combat that issue. So making a persistence tool. Of all the cool techniques I just mentioned, they all have one weak point. The file has to exist. The file always has to exist. And this is the problem that I personally kind of set out to solve with my own tool. And you got to consider that nearly anything is removable given enough time. You just have to make it hard enough that no one bothers. Make removing your malware so time-consuming that no one actually wastes their time doing it. Blue teamers are juggling a million things. They're defending multiple boxes. They're doing injects. They're doing all this stuff. And they don't want to spend 15 minutes just to remove one of the 10 C2 servers that are running on their computer at once. And because persistence is persistence, it's also really annoying to test. You just have to like make VM snapshots and revert it every single time because like it's so hard to make it stop running because that's the entire goal of it is to make it hard to stop running. So that was kind of an issue I encountered when I was doing all this. So for my tool, I kind of had some struggles with the more niche persistence techniques. They sometimes rely on older versions of Windows, and sometimes they can just be a lot less reliable. And I just found simpler is better, and it might not work across different infrastructures or different versions of Windows that I might encounter in the competition environment. So really what I ended up using was just the classics, run keys, schedule tasks, and then a whole lot of iteration and firewalls. Firewall rules. So my thought process when making my tool is that run keys and schedule tasks are pretty normal. How do I make sure that people just don't delete them or disable them? And my solution to this was just iteration. Basically, I'm going to iterate through the registry and make sure that any changes to that registry key or any modifications or deletion of it is made again, and my registry key is always there. So they can't restart the computer without it being there. So what if the binary is stopped or deleted? Now I'm going to put in watchdog processes. These are processes that are going to sit there and make sure the other process is running. And if the process is deleted, it's going to put it back. If the process is stopped, it's going to start it again. And they're just going to always be there watching each other. So what happens if both the watchdog and the payload get stopped or deleted? Then we have another watchdog. The watchdog is going to run, it's going to watch everything. The other watchdog is going to watch everything. So now if you delete or stop anything, there's going to be something there that will bring it back up. And then what if the firewall blocks C2 communication? So now I'm going to have it watch the firewall as well as the other processes. And now it's going to make sure the firewall has certain ports open that are going to make it so whatever C2 or service I'm using for my malware is going to be still available. And this is kind of what I came up with. This is just kind of a little diagram of what it is. So basically, I have the main watchdog process. Every so often, this is going to be going through the registry, making sure my run keys exist. So anytime that it restarts, it starts up again. And it's going to check the firewall, make sure that it's always running. Make sure that the ports I need are always open. And it's going to go into scheduled tasks, make sure whatever scheduled task I have to run it every minute is still there and still running. And then that's going to watch the secondary watchdog process as well as the payload. So if either of those two, if you could delete both of those things, and the main watchdog process will put them both back and run both of them. And vice versa. You delete this and delete those two. You delete those two and leave this here. That's going to bring the rest of those back. So basically, you just kind of have a way to make sure that everything's always there, everything's always running. And it's just kind of a simple way using iteration. So in doing this, I found also some other features. My tool should write Ansible to self-deploy itself. It's a little bit buggy as Windows Ansible tends to be, but it should work for any .exe payload. It persists on on reboot when run keys are deleted and changed, when firewall rules are made, when scheduled tasks are created or deleted, or when any watchdog or any payload is deleted or modified. So what should you do? As I outlined, there's a lot of ways to persist. You can be really stealthy. You can do these iterative watchdog approaches that I did. You can use fileless techniques. You could be very loud like I am with just running a million things at once. You can rely on DLLs or you can rely on EXEs to keep running your program, but you should really just do whatever suits your tool, whatever suits your goals. If you're trying to make something really stealthy that no one's going to find, you should put a lot of time and research into that. And also, one thing I like to do is just make like really silly Windows sounding names. Like I have stuff running on Blue Teamers computers called Windows Service Management, WinLogoff, or like Windows Disk Optimizer, like stuff that just like, if you actually know Windows, it's just like a slight variation of like actual stuff that exists. Like, look at this ASA guy. But yeah, I know WinLog. I love that one. Like, no one noticed. It's so funny. But yeah, thank you. Don't waste your hard work. Make sure your tool is always sticking around on Blue Teamer's computers. And if you want help with Windows persistence, DM me on Discord at Willow317. Come to Red Team Recruiting and make a Red Team tool. Do you guys have any questions? Hayden. What are Blue Teamers supposed to do about that? I mean, I'm not going to tell you how to get rid of it. There's definitely ways you can do it. You just gotta put some thought into it. Any other questions? Asa. It is malicious. Because I'm making things run forever. Philip, how would you get rid of this?
I wouldn't.
If you find that running on your computer, what would you do?
I'd just keep downloading more of it.
Yep. If you ever have problems on Blue Team, just make sure to sit there and do nothing as we have illustrated today, and let Red Team have as much access and as much fun as they want.